Hello, in this video I wanted to talk about list virtualization. I want to talk about what it is and also how we can implement it using the library from TanStack called TanStack Virtual. So let's jump over to an example. This is an application that I have made called TF It's a Wordle type of game where you're supposed to guess the day's weapon. So every day there will be picked a random weapon and your job is to guess in as few guesses as possible what weapon it is today. Now, it's not that important what the game is all about. The important thing is that when a user starts typing something in this input, we want to show a drop-down of all the weapons. Now in TF2 there are about like 200 weapons or something. So when you scroll ahead, there are so many things to pick from. And right now everything is rendered as a single div, every single one of the items. So if you check the console, we can see that each item is rendered as its own list. And we can see that there are so many elements down here that are rendered, and we can only see like 6 of the weapons at a time. So you see when I hover over these elements, if I go all the way to the top, we can see the first one, but then there are so many more underneath it that we don't even see, so there's really no reason to render it. And this is where virtualization comes in. It's a technique that we can do to render only content so that we will fill up the container. So in this example, this will be the dropdown. And then we can simulate that it's a long list, but what we do is that instead of rendering every element for every item in the list, we render just enough amount of elements to cover up the container, and then we swap out the content in the element, and also we animate them so it looks like we're continuously scrolling. So in this application, it's not that big of a problem because there's only like 200 weapons, and it's fine to render 2 elements like this. Now, if you have a list of, let's say, 1,000 elements or even 10,000 elements, then this could become a big problem and slow down your web page like quite significantly. So let's take a look at how we can fix this using virtualization. So in this example, this is using the same list of elements. We have a list of weapons from the TF2 game, and we are rendering them as a list, and as you can see, it looks the same. Of course, this is not a dropdown, it's just a list on a blank page, but you can see we have the scroll bar and it looks like it's just a long list of things. But if we actually check the DOM, we can see that there is only like, I don't know, 10, 20 elements over here. But when we scroll, you can see that they are updated, getting animated, and also the content of them are switching out. So instead of rendering all the 200 divs, we only rendered the things that are visible, plus some more at the bottom, so that we can like animate them up, and also some on the top. But mainly only divs in the middle that we actually see. So from the user point of view, this looks the same, but this will prove performance on your application because you don't have to render as many divs. So on the left here, we have the code to implement this. Let's first take a look at the HTML mockup. So what we have is we have this div with, which is going to be the parent. This is the div or the container that we want to render every item in, and this has to have a fixed height so that we can calculate when to swap out the elements and when to add new elements and so on. Then we have this inner element, which gets a height of this row virtualization. I'm going to show you what this is later. But essentially, this is something we get from the TanStack library, and we just set that as a height of the inner element. And then finally, we again use this row visualizer, which is again provided by TanStack. We get all the virtual items. The virtual items are basically only the things that are actually shown, not the entire list. We map over them, and then we render a div for each one of them. We set them some styles of absolute, top, and whatever. And a transform so that we can animate them when you scroll just a little bit. And then we can use the index from this virtual item to actually get the correct weapon from the entire list. Now, if we go up, this is where we initialize our virtualizer. We're using this useVirtualizer hook. We're giving it the total number of weapons. So this is just a list of weapons. We just take the length of it. And then we're giving it a reference to the parent ref. This is the first div or the outer div, which we just bind to a ref in React. And then finally, we tell them an estimate of how big each item will be. So in this case, this is 35 and this is 35 pixels. So if you see on the right, these elements over here, like each element is like 35 pixel high. If you make this to 100, we can say, when we refresh, we see that now each element are much higher. We can only see like 4 elements at a time. And what is really cool about this is we can combine this virtualization effect with TanStack Query's InfiniteQuery hook. because in this example that we have right in front of here, we're loading all of the items into memory, but then we're only rendering a subsection of it. But when you have a really big list, let's say 10,000 elements, you don't really want to load all of that into memory at once. And this is when you want to use something like InfiniteQuery. So if we go over to example, it looks exactly the same. But the difference is that when we go into the network tab, I'm going to refresh so we clear all the cache. I'm going to also clear this terminal. Now, when I start scrolling, you can see that we're starting to fetch more and more weapons, so we don't fetch everything at once, only when we actually need it, we fetch it. But from the end user, it looks exactly the same. And the way that we achieve this is that we use the InfiniteQuery from TanStack Query. This is how it's implemented. We give it a query key, which is weapons. This is just a key to extinguish it from other queries. Then we have this query function, and this is just calling the get weapons. Now, in this example, I am using TanStack start, so this is a server function. But this could be an API call or whatever. The important thing here is that we're passing in a limit. This limit is defined up here, it's just 10, so we're fetching 10 weapons at a time. And then we're passing in the offset, so from where we want to start. So in the beginning, the offset is 0. And then when we scroll down, the offset will be 10 or 11, and then so on and so on. This uses the context from the InfiniteQuery to get the page param. And the function down here is defining how we get the next page param. So we're taking the last page. A page is, in this InfiniteQuery, is basically whenever you do a fetch, you get a page, and that page contains the items in that fetch. And then when you do the next fetch, you get another page. So you can think of it as like a chunk. A page is a chunk, and then we take the previous page or chunk, and then we get the next of it based on that. And you can see if we go up to my server endpoints, so this is my get weapons server function in TanStack start. Here we just have a guardrail saying that if your offset is more than the weapon length, then we just return an empty array because there's no more weapons to look at if you have scrolled this far. Then we calculate this next offset, which is going to be the offset that we provided to this endpoint plus the limit. And then again, if that is more than a weapon, then we return undefined, otherwise we return the next offset. And then we use this in this return statement, which returns part of the weapon based on your offset and your limit. We also return the total number of weapons, so this will only be a number of how many items there actually is in this weapons array. And then we return this next offset, which we define up here. And this is why we can get this next offset in this get next page param property. And then we're setting this initial page param to 0, meaning that when we start to fetch, we want to fetch from offset 0, so we get the 10 first weapons. And then this useInfiniteQuery has this fetch next function that we can call. So when we call this, it uses this next page param, and then it fetches the next 10 weapons from wherever it was previously. So if you only fetch once, then it will fetch from 11 to 20. And if you fetch twice, then we will fetch from 21 to 30. Then we're doing the same down here. We're having this paragraph, which is going to be bound to the outer div. If we go all the way down here, you can see we have this outer div, exactly the same as we did in the other example. The main difference now is that instead of having all the weapons loaded in memory, we take the weapons from this data, which is something we get from this useInfiniteQuery. As I said, we have pages, so the structure will look something like this. So this line right here just maps it so that we have a single array looking like this. And then from the query, we get the total number of items. We pass it into the calc so we can calculate how long the list will actually be. And then we do the same, passing in the scroll element, which is going to be the outer div. And then the same estimate size of how big each item will be. Then finally, we have this effect down here, use effect, which takes the last element of this virtualized items. So again, these virtual items are the items that are actually rendered in this list. So if we take a look at the console, we can see these are going to be the virtual items. We get the last one, and then if there is no last element, we just return, we don't want to do anything. But if the last item's index is more or equal to all weapons, and these all weapons are like all the weapons that we currently have loaded in our client, and there is a next page, and we're not fetching the next page, then we want to fetch the next page. And this will automatically populate this all weapons list. So when we go down to when we want to render it, we again take this weapon virtualizer, we're getting all the virtual items, we're mapping over them, we're rendering a div. And then we have this weapons array that we take the index based on the virtual item and we render the name of it. So combining these two concepts of virtualizing your list and also implementing InfiniteQuery with something like TanStack Query, you get this nice behavior where you only fetch what you need to do. Your DOM doesn't get overpopulated with thousands of div, but you get the same experience for the end user. And this is also optimizing your web page so it will feel smoother and quicker. That's all I had for this video. If you want to check out the code, there will be a link to the GitHub in the description. If you have any comment or feedback, please leave a comment and I will see you all in the next one.